Problem 12. Let segment AB be a diameter for circle AB, for the circle rather, with AB being 24. Point C not equal to A or B lies on the circle. As point C moves around the circle, so for example, let's say this is point C right here, as it moves around the circle in this fashion, it produces a centroid when you make a triangle of ABC, traces out a closed curve, missing 2 points. Alright? To the nearest positive integer, what is the area of the region bounded by this curve? So we get it. So let's say this is C. We connect the line to get a right triangle. Because remember, if the hypotenuse of a right triangle is the diameter, then this is, a right triangle. So we have this, we have that. That's obviously a right triangle. So now that we have this, the centroid is basically connect all the midlines. So we connect the midlines, you get a point that's somewhere around what? Somewhere around here, for example. And what happens, or rather, that's a bit too far, like right here. What happens is that as you move C, this centroid moves along with C. So basically, you create boom, 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 boom. You create a circle when you put C, revolve it all around this circle. And we're basically trying to find the inner circle's area. But how do you do that? Well, we know that if we were to connect this line right here, this crosses the, oops, that's a very bad centroid. Let's make it a bit more accurate. So the centroid will look probably somewhere around here. That's roughly more like it. Or somewhere right here. Alright, it doesn't matter. So let's say this is the point. That's a centroid. There's a formula in the centroids for a triangle, which is that this side is 2 and this side is 1, meaning that it's a 2-to-1 proportion. But you know that this always passes through the center of the circle. That's important because whatever line that passes through the center of the circle becomes a radius or a diameter. And obviously, if you make this into a circle, then, well, this side length would be your radius. And then you have the radius to find the area. So what is this length then? Well, CO here. CO is the radius, right? So the radius of this large circle will be equal to 1/2 times the diameter of 24, which is equal to 12. So CO, right, is equal to 12. But we know that if I call this F, we know that OF, right, compared to CF is 1 to 2. So if that's the case, then OF will be equal to 1/3 of OC, the entire length, right? So then this is equal to 1/3 times 12, which is equal to 4. If you have the radius, then you have the answer. Area is pi r squared, 16 pi. Pi is roughly 3, so that becomes roughly 48. So your final answer will be answer choice C.